We're now going to continue this tutorial in the directory under your home directory in the ROMs mapping directory, and we will learn how to read a netcdf file from MATLAB. Okay, to do that I created a file called main.ncdf.m, which is basically contains a set of tutorials that we are going to use for this purpose. So this set contains 4 tutorials. The first tutorial is using the MATLAB netcdf interface to read and write a netcdf file. So before going through this tutorial, let's open in another window a MATLAB session. So I'm going to go into this black window. I'm going to go in my home directory, then in ROMs mapping, and I'm going to run MATLAB. Okay. So the netcdf interface in MATLAB, the very low-level interface, is just called netcdf. So if you type help netcdf, you'll find a whole bunch of examples and help, of all the functions and routines that are associated with this package. Okay. But very basically speaking, the idea is that the first thing you want to do is you want to open a netcdf file. So for example, let's define a variable nc equals netcdf. And then we're going to give as an argument the name of the netcdf file that I want to open. So let's paste it there. Okay, so now this variable nc is a pointer to this file. And for example, it tells you basic information, like for example, it has 1,842 records. Now, if you recall, we used the ncdump command to look at the content of the netcdf file inside, from the Unix shell. We can also use this command from the MATLAB to see the content of the netcdf file. And we can just do this, and this will dump, all the information of the variables, so the dimensions, the variables, and so forth. So for example, if I want to access the SST variable, I can just do nc of SST, and this now is a pointer to the sea surface temperature variable. So now it sees this variable here is SST, short, it has dimension of time, long, lat. These dimensions are 1,842, 89 by 180. So if I now want to access the value of this variable, suppose I'm going to say SST equals the pointer, and then I'm going to open the parentheses and put colons like this. And this will say basically that I'm going to take the entire first dimension, the entire second dimension, the entire third dimension, which is the entire content of the variable. Now suppose that I want to load only the first time record. So then I go back here and I just put 1. Okay, then I put a semicolon here and I just load this variable. So now I have loaded in MATLAB, a sea surface temperature variable, which is 180 by 89. Now I can open a figure and p-color this variable using shading flat and color bar. And this is what I see. Okay, so this variable is upside down, and you can see that you can't really tell the sea surface temperature field because you have these big red regions over here. And these red regions have very high values. And if we go back to the definition of this variable using the ncdump command, we find that there are some missing values defined in the SST as being equal to this. So we have to actually take these values out. There's also an offset value that a scale factor that we have to use. And so we have to use these kind of things to actually read correctly the variable. Okay, so let's go then to this window here and let's look at a more complete example. So the file that we want to read is the NOAA SST file, which are, in this case, these are monthly mean sea surface temperature values that I downloaded from the Climate Diagnostic Center. So once again, in my script, I open the file with this pointer called nc. In this script, I load the longitudes and latitude arrays so that I can have the coordinates of the grid and also the time. Then I take the longitude and latitudes arrays that are just single arrays, and I create a 2D grid of the longitudes and latitudes that I will use later to plot the thing. Then I do some operation on the time array. So the time array, if we go back to the MATLAB window, and we go further up. So here we have the time array. You find that the units are days since January 1st of 1800, of year 1800. So this type of unit convention is one that is typically used, for example, in data that you download for the NCEP reanalysis NCAR data sets. However, in MATLAB, we want to convert this time into the MATLAB unit time units, and we can do that by using this command called in datenum. And so what we do is we say, okay, time, this is times in days already, and datenum is basically also time in days in MATLAB, but the reference point is different from the 1800, January 1st of 1800. Datenum itself starts, if you do help of datenum, the reference point for datenum is date numbers or serials where 1 corresponds to January 1st of year 0. So what we do then in here is we just add an offset, which is the this particular value here, and we can see what that value is. So January 1st of a year 1800 is equivalent to day 60. What is it? 657,000, etc. Okay, so that's loading the time. Then I'm going to convert this time, which is in days, since now the datenum command, and we're going to convert these in year, months, and days. Okay, so that we can have the whole thing. We're then going to find a record of the whole time, which is year 2002, and month equals February. And then we're going to finally load the sea surface temperature for that particular record. And so I'm just going to use the nc command here. And then I'm going to put the SSC, the time record that I want to load. And then, I'm going to load the entire X and Y directions. I'm then going to permute this SST array, because if you remember in the definition of this SST array, if we look at the NC dump again, you find that this is defined as time, longitude, and latitude, and this is a reverse convention. I want to have my array be longitude, latitude, time, so I'm just going to permute this particular record by using the command SST equals perm of SST. I'm then going to read the value of the missing values by accessing the SST variable, but of the SST variable I want to access the file, the field containing the missing value. In this case I can do it this way. And then I'm going to say that for each SST that is equal to this missing value, I'm going to set it to nan, or basically which is a nan value in MATLAB. I'm then going to use the scaling factor to, I'm going to read the scaling factor from the SST file here, and I'm going to use the scaling factor to then multiply the SST by that scaling factor, and at that point I'm going to be done. So let's execute all these commands here. Okay, let's go here and let's paste these commands in here. Okay, so now we find, for example, that when we look the location of year 2002 month 2, this is actually record number 1778. So for example, if I do time of 1778, these are the number of days from January of year 0, 1st of January year 0 in the MATLAB convention. And if you want, you can always convert that into a date string by using the date string command. And if you do this, you'll find that this indeed is February 2002, which is what we were what we were looking for. Okay, so now if I do a size of SST, I have my SST array, and I can plot this. And in this case, I'm going to use the RNT contour fill command, and so I'm just going to do a new figure, and I'm just going to plot this, and I'm also going to put a world coast just to see the continents and stuff. And so I'm just going to do this whole paste this whole string here. And now we have a nice SST field. You can see that the land mask has been masked out. There's all the SST values here that are in degrees Celsius, and you can clearly see the tropical bands and so forth. Okay, so now we've learned how to access, for example, a NetCDF file. In this case, the SST from the NOAA website. Okay, so this is going to be the end of this first tutorial.